Hi, my name is Bob Zolo, and I'm an engineer with Agilent Technologies. Today I'd like to share with you this exciting new product from Agilent called the Advanced Power System, which is a new family of power supplies available in 1 and 2 kilowatt models. The Advanced Power System was designed to solve tough power test challenges. Today I'm going to demonstrate for you how it solves the power test challenge associated with protecting the device under test from power-related damage. During this video, I'm going to show you 3 examples of 3 features related to power protection. Now, things like overvoltage protection and overcurrent protection are common in the industry, but the features I'll show you today are new and advanced beyond simply overvoltage and overcurrent protection. So, what we're going to show here first is a protection feature which we call the Watchdog Timer. The purpose of the Watchdog Timer is to shut off the power supply if it doesn't receive any commands from one of its interfaces in a user-programmable amount of time. So by one of its interfaces, I mean no commands over LAN, USB, or GPIB. This would be a case where perhaps the computer crashed, or a wire was cut, or for some reason communication was lost between the power supply and the device under test. Now, let's say the device under test was a battery, and you were using the power supply to charge a battery. If while you were charging that battery, the computer were to stop talking to the power supply could potentially overcharge the battery, which could be hazardous. So the purpose of the Watchdog Timer is to shut off the power supply when it loses communication. With this test setup, we're powering these light bulbs with the power supply. I've got the Watchdog Timer set up to turn off in 5 seconds. To demonstrate, I'm going to pull the LAN cable from the back of the power supply. In 5 seconds, the lights will shut off automatically. So here we go, pulling the cable, 5, 4, 3, 2, 1, and there they go. The Watchdog Timer protected against the loss of communication. In this demonstration, we're going to demonstrate a protection feature which we call windowing. Now, the windowing function can be used to put a window of limits around the output voltage, the output current, the output power of the power supply. In this particular case, we'll be windowing around the output current. We have the power supply powering the light bulbs again. Now, in this case, each of the light bulbs pulls about 400 milliamps. We've got a high threshold set at 1.4 amps. So if this set of light bulbs ever pulls more than 1.4 amps, the power supply has been instructed to shut off when the current exceeds the 1.4 amp threshold. We've also got it set up that if it ever goes below 1 amp, it will shut off. But for this first case, we're going to be demonstrating exceeding the high threshold. So right now there are 3 bulbs on. That's pulling 1.2 amps. The threshold is set at 1.4. When I screw down this next bulb, the current will jump from 1.2 to 1.6, which will exceed the threshold and turn the power supply off. So let's go ahead and do that. So as you can see, it automatically shut off when the current was exceeded. Now we're going to demonstrate the low threshold, and what I'll do is I'll remove one of the light bulbs from the string. When I take the light bulb out, the total current will drop from 1.2 amps to 0.8 amps, which is below our 1 amp threshold, and will turn the power supply off. So let's go ahead and unscrew this light bulb. And as you can see, when the current went too low, the power supply turned off. In this third demonstration segment, what I'd like to show you is a feature we call Sense Fault Protection. Now, these power supplies offer remote sensing or 4-wire measurement. However, many power supplies on the market, if a sense lead should come loose or break, the output voltage of the power supply will fly up to its maximum because the feedback through the sense line is no longer available to the power supply. With the APS, we have Sense Fault Protection. Should a sense line break, you can instruct the power supply that if a sense line should break, we should turn the output of the power supply off. So we're going to demonstrate that right now by cutting a sense line. We've programmed the power supply so that if the sense line is removed, the power supply should automatically shut off. So here we go, slippers, and as you can see, the sense line is cut and the power supply is turned off. So what you've seen in this video is a demonstration of the features of the Advanced Power System for addressing the test challenge of protecting the device under test against power-related failures. For more information on the Advanced Power System, please see the URLs that are listed on your screen right now. Thank you.